In this lecture, we'll be starting to study about CPU scheduling. CPU scheduling is a very important topic in operating system, and it is a topic that you should really know about whether you are studying about operating system in general or if you are preparing for any exams of computer science in which operating system is a subject. Then this is a topic from which you may get many questions. So this is a really important topic, and let us try to understand and see what is the CPU scheduling and what it does. CPU scheduling is the basis of multi-programmed operating systems, and by switching the CPU among processors, the operating system can make the computer more productive. Multi-programmed operating systems, they work on the basis of the CPU scheduling. And why is that? And that is because by switching the CPU among processors, the operating system can make the computer more productive. Now you may be thinking, why did we say by switching the CPU among processors? So this is the actual thing that is going to happen in CPU scheduling. We are going to switch the CPU among different processes, and thereby we are going to see how the productivity of our computer is going to improve. So don't worry, even if you don't understand what this means right now, it will become clear when we go into the details of CPU scheduling. So now let us see what are the important topics that we need to cover under this topic of CPU scheduling. So the first thing that we are going to do is to introduce CPU scheduling, which is the basis of multi-programmed operating system. So I already told you that CPU scheduling is the basis for multi-programmed operating systems. So we will introduce CPU scheduling and see what it actually means, what it actually does, and how it makes our computer more productive. And secondly, we are going to describe the various CPU scheduling algorithms. So there are different ways in which CPU scheduling can be done. So we will see the various algorithms that we have which helps in accomplishing CPU scheduling, and we will see how these algorithms differ from each other, and we will see which of these algorithms perform better in particular situations. So these are the main topics that we are going to cover. First of all, we'll study what CPU scheduling is, then we'll look into the algorithms. So these two topics are very important, and we will try to go into the details of these topics, and we will try to make CPU scheduling very clear to all of us. So before we delve into the details of CPU scheduling, let's first get the basics right. Let us first try to understand in a very basic and in a very simple way what CPU scheduling means, and then we will see what is the importance of CPU scheduling. And after getting the basics right and after trying to understand it in a simple way, we will go into the details in the coming lectures. So coming into the basics, let's talk a bit about single processor systems and multiprocessor systems, which we have already studied before in this lecture series. So in a single processor system, only one process can run at a time. So we know that in a single processor system, there is only one processor. In that one processor, only one single process can run at a time, and any other processes must wait until the CPU is freed and can be rescheduled. So when one process is running, we have to wait until that process is completed, and only after that any other process that is waiting can be given the CPU for its own execution. So this is what happens in single processor systems. But we already saw that we have multiprocessor systems as well. So multiprocessor systems were much better because there are more number of processors, and hence there can be more number of processes running simultaneously at the same time. So the objective of multi-programming is to have some process running at all times to maximize CPU utilization. So we know that the objective of multi-programming is that we want some process to be running at all the times so that the CPU is always utilized by some process. So a process is executed until it must wait, typically for the completion of some I/O request. So when a process is being executed, let's say that it is using the CPU, it is using the processor, the CPU, and it is being executed, and that process is in hold of the processor. And what happens is that when that process needs some I/O executions to be done, then what happens? It requests for the I/O operations to be performed, that is input-output operations to be performed. And until and unless that I/O operation is not complete, it has to wait. So while it is waiting, what happens is that it is still in hold of the processor, but it is not using that processor because it is waiting for the IO operation to be completed first. So what happens is that in a simple computer system, the CPU then just sits idle and all this waiting time is wasted and no useful work is accomplished. So when a process is in hold of the processor and while its execution was being done, if that process needed some IO request to be complete, then it has to wait for that IO request to be complete. And while it is waiting for it to be complete, it is still having that processor with it, but it is just waiting and that processor is not being used at that time. So the CPU is just sitting idle, and then all the time that it is sitting idle, that time is wasted because nobody is using the CPU at that time. Hence we see that there is going to be a decline in our productivity because of this factor that we have seen here. So the basic need for CPU scheduling is to avoid this. We don't want the CPU to sit idle at any time. So what we want is that if there are processes available, then we want the CPU to be utilized as much as it can be. We don't want the CPU to sit idle. So in order to accomplish this, we are going to introduce CPUs.